Jet engine. It is a reflex thrust engine that does not need a mechanical kinematic combination, and contains a special design variable section stream where the combustion gases resulting from the burning of the used fuel rush. The gases flow occurs at a great speed, often exceeding the speed of sound. And based on the principle of reaction, the necessary thrust force is achieved to push the body of the jet engine linear moving. The jet propulsion engine is called pneumatic when the surrounding air is used to burn fuel, as in jet engines, and the missile propulsion engine is called the rocket engine, when outside air is not used for combustion, as in missile propulsion engines. The heat engine may be a combination of two types of engines, such as the turbojet engine and the turbopropeller used in aircraft. In the first type, the remaining kinetic energy is used to achieve the thrust needed to push the engine body from the jet tail cone nozzle. In the second type, the gas turbine secures the movement of the fan, which pulls the air and pushes it behind it, thus achieving the necessary propulsion forces, and part of the pushed air passes to the compressor, which in turn pushes it with a certain pressure into the combustion chamber. So the combustion gases loaded with energy are directed to the turbine, and the gases follow their way to exit through the nozzle of the jet thrust chamber. Rocket engines. Another example is the rotary piston engine. Wankel engine. The outer flatness in the rotor, ABC, represents a piston in which there is a combustion chamber and forms with the inner surface of the fixed engine body the effective working volume. It rotates with an eccentric displacement around the axis of rotation. The rotor is connected to the shaft of the output mechanical power take-off through a pair of gears with internal engagement. With the rotation of the body with its piston surfaces, the pressure and temperature of the gases change. During one working cycle, each surface performs all the strokes of the engine: drag, compression, combustion, expansion, and then expulsion. The engine adopts a thermal cycle, like a spark ignition engine, often, and is characterized by smoothness in work, high rotational speed, and large horsepower relative to its weight and size. It can operate on low-octane fuel, and the engine requires good alignment of its fixed and rotating parts, high precision in its manufacture, and is characterized by a relatively high rate of fuel consumption. It was used in limited use in motorcycles, cars, boats, and helicopters, and it did not become widespread, although it could be developed, especially in terms of fuel consumption, to become one of the best engine systems in terms of power and torque, but it did not spread for reasons that will be explained later. Fuel. The combustion of fuel in the internal combustion engine is the main source of thermal energy that changes the pressure and volume of gases inside the engine. To understand what is meant by fuel combustion, it is necessary to know the chemical composition of the fuel itself. To clarify the chemical union of the elements, we have to summarize the following. The element is the basic substance that cannot be broken down or broken down into other substances such as oxygen, hydrogen, carbon, sulfur, etc. The atom represents the smallest part of the element, and by breaking it, the element loses its properties and turns into the common components in building all materials, which are protons, neutrons, and electrons, which form the basis of atoms of different materials when their images change together. The atoms of one element are usually similar in composition, but the compound consists of atoms of two or more different elements, as is the case in the carbon dioxide compound, which contains atoms of carbon and oxygen. And the molecule consists of the aggregation of two or more atoms of one element or different elements to become an independent unit whose atoms hold each other together with the strength of mutual attraction. In other words, the element or compound part represents the smallest part of it that can retain its distinctive image, whether in terms of composition or properties. Diesel engines, such as oxygen and hydrogen, each of which consists, respectively, of two atoms of oxygen or hydrogen. All circulating materials are symbolized by their own symbol, which shows their chemical composition and the reaction that occurs to it. Carbon, for example, is symbolized by the letter K, and the oxygen molecule by the symbol A2, which indicates that the oxygen molecule contains two atoms of it. And the oxygen molecule unites with the carbon molecule that it expresses. With the symbol Ca2, the meaning of carbon dioxide is that it contains two oxygen atoms. The atomic weight. We know that the weights of all the atoms of one element are equal, but they differ among themselves with respect to the different elements. The weight of the oxygen atom is much heavier than the weight of the hydrogen atom. Since hydrogen is the lightest of the elements, it has been agreed that the weight of the atom is considered the standard unit for the atomic weight of materials. The atomic weights of the different elements are estimated by comparing them with the weight. The atomic number of hydrogen. Table 2 shows the atomic and molecular weights and chemical symbols of some elements involved in the fuel combustion process in engines. Air is considered the main source of oxygen required for the combustion of fuel in engines, and it is a mixture of gases that are not chemically united with each other. So it cannot be considered a chemical compound, and oxygen is within the total number of these gases, and the rest is mostly nitrogen, which is mixed with small amounts of other gases. They do not enter into the fuel combustion process, as they are called inert gases. The table shows the percentage of air composition. Engine combustion chemistry. Fuel oil, petroleum derivatives, used in engines consists of a mixture of hydrocarbon liquids, which are chemical compounds consisting of the union of hydrogen gas with carbon in different proportions, upon which the final form of the compound depends. Carbon with 6 hydrogen atoms, while propane and its chemical symbol, K3 plus H2, contain 3 carbon atoms united with 2 hydrogen atoms. As for the gas that is used as fuel in engines, it also consists of hydrocarbon compounds, and it may be mixed with carbon monoxide gas. It is clear from the foregoing that the combustible compounds present in the fuel used in engines are based on carbon and hydrogen. And some of them contain sulfur, which is a flammable element. For combustion, however, it is undesirable, but it is found in small proportions.
Do not forget to subscribe to the channel and support us to continue and provide everything that is useful to you.
Thanks for watching.